Okay, we're live? We're on camera? All right, this is the review session from in class on Friday for Math-3. Here's the answer key. I'm going to talk really fast because we got to do the entire thing in just two 15-minute chunks. All right, so Unit 5 is all about functions, and there's going to be at least one question on the exam about what is a function. Basically, you just want to know that when you plot an input and an output, that it'll pass the vertical line test. So if you plot those points right there, does it pass the vertical line test? Heck yeah, it does. Each point, you go out to 1 and up to 3, so you get horizontal dots like that. That's okay. This one, if you plot these, you get a row of vertical dots. You go out 3, then you go up 1 and 2 and 3, and so it fails the vertical line test. This one fails the vertical line test because if you plot x's, you get 2 different y's that are going to work and make that 16. Okay, so if you interpret x's to be your inputs, you get 2 possible y's. If I made x 0, I could have +4 or -4, and it still makes 16. And it's not right to have 2 different outputs for one input. 0, for instance. All right, so this one, that is the check mark for that one. All right. So now this one, find all the zeros. All right. So when you are going to look for zeros, if they're easy, just factor them. So I'm looking at this and I'm seeing that there's a 3, a multiple of 3 in each of those. There's also an x in each of those. So I'm going to take out and write f of x is equal to 3x then times x squared minus 4x minus 5 then, okay? And I'm trying to break it down to see what multiplies to make that top polynomial, all right? And in this case, I can write f of x still has got the 3x, but I can break this down and have it be x minus 5 and x plus 1, all right? So these are 3 factors that will make that top polynomial. So this is in standard polynomial form. That's the lead coefficient, 3. It happens to be a coincidence that the degree is also 3, but know what each of those are, okay? This does not have a constant term. There's no number that's being added out there. That allows us to factor out the x. Then you want to ask, when is each of these equal to 0? That's the critical thing. The only way you can multiply and find a 0, that's when these are going to be equal to 0, is when each of the multiplied products is 0. So this happens when x equals 0. This happens only when x equals positive 5. And this happens only when x equals -1. So these are the 3 zeros that will, when plugged in, give you a 0. All right. Next one. This is what's called a rational function. It's a ratio of 2 polynomials that cannot be simplified. Okay. If I had something that could be reduced to a single, fraction that's broken down or a number, it would not be a rational function. But this cannot be simplified any further. All right. We're going to graph this and show all the key parts. To do that, I'm going to not answer my phone, but I'm going to get another color marker. Can I have another marker? All right, here we go. Oh, thank you. Didn't catch that. All right. So, to graph this, we have to, again, ask the question, when do we get division by 0? All right? So I'm going to factor this. X minus 4 and x plus 4. That is going to show me that I get division by 0 when I have x is equal to 4, that's my asymptote there, and -4, that's my asymptote there. Vertical asymptotes are boundaries that as the function approaches, and the function can be here, but as the x values get closer and closer and closer, they're going to do something crazy, go up or go down towards positive or negative infinity. I will have the function in here. It's not like the function stops and can't go beyond it. It will be over here and over here, but it'll behave very strangely when it gets closer to those vertical asymptotes. Okay? Then you have to consider where your horizontal asymptote might be, and that's a battle between the numerator and the denominator, and you've got a checklist to go over exactly how that works. But mostly, if the denominator wins, if that's got a higher degree, as x gets really large, the denominator will win and get very, very large. And so a small number over a very large number gets closer and closer to 0. So this one has a horizontal asymptote that's 0. Okay? If that had been 3x squared, then the degrees would be tied, and the other numbers that are less degree have much less importance, and you can ignore them and look only at the lead coefficients after basically canceling out those equal degrees. Okay? If that wasn't 3x squared, you'd have a horizontal asymptote of 3. If this was 3x cubed, or 4th or 5th degree, and the numerator wins, then you have no horizontal asymptotes at all, okay? So sometimes you have none. The horizontal asymptotes you can cross, you especially can cross, you expect to cross them in the middle. All right, so if we plot points, this would be a great time to type that into the calculator, so I have an assistant that will do that, and I'll show you this in calculator form in a second. However, it's worth noting the domain and range, okay? The domain is the allowed inputs, so for the domain, I'm going to be allowed to put in all real numbers, but x cannot be plus or minus 4, okay? The range is the outputs, and we'll have a look at the graph and we'll see. I know that when I plug in 0 for x, I'll get 0 for y, and I believe that when I plug in my x values that are close to -4, they go like that. When they get close to +4, it goes down like that. So just on the strength of this part of the graph alone, you can see that the range will be all real numbers, that there's any y value I can get, positive or negative. Okay, so taking a look at that graph then, you can see that it's going to be something like that, where it swoops up on the right and then comes down towards that horizontal asymptote. And then it swoops down like this on the left-hand side, okay? So you do not need to label a lot of points. You just need to show this is the horizontal asymptote is equal to 0, and these vertical asymptotes are at -4, and x equals +4, okay? Moving right along, we've got a, this is sort of from our transformations section, where we're looking at like a parent function, and we're moving it around. I'll take another colored marker if I could, maybe red. Thank you, here it comes. All right, so this is the original function we're asked to graph, but the parent function for a square root function is just going to go something like this, okay? Without any numbers, you don't need to be hung up about where to put a second point, but we know that that starting point, the belly button point, is at the origin, okay? So we're going to move this in a positive manner towards the A, and then we're going to flip this, which this flips it vertically, or flips it over the x-axis. So we'll move it to right here, okay? And then we'll flip it so that it's like this. Best actually to think about flipping it first and then moving it. In this case, it doesn't make a difference. Then from here, we're going to move the whole thing down to B. So it's going to be down to -b. So that's what our graph will look like that. And you could just label this point +A, comma, and -b. All right? So the domain, again, what's the domain of this? We can plug in any x value as long as it's greater than or equal to A. So all real numbers, x is greater than or equal to A. What's the range? What numbers are coming out? Looks like anything down below will come out. So it's going to be all real numbers. But f of x is going to be less than or equal to -b, okay? Now it says find the inverse, okay? So to find the inverse, I'm going to sneak it in right here. You're going to switch this to y and then swap the places of those. I'll do that in one step. Y is equal to -square root of x minus a minus b. I'm going to add b to both sides. Y plus b equals minus radical x minus a. Then I'm going to swap that negative sign over to this side. So I'm going to make it negative right there and positive right there. Then I'm going to square both sides. So I'm going to put in parentheses minus y plus b. And then 2 parentheses, and I'm going to square that. Well, that's going to be equal to x minus a. So all I need to do is add a to both sides, and then remember to write it. F to the -1 of x then is equal to minus y plus b, close parentheses squared, and then plus a. Okay? So that is the inverse. And then it says graph it. So I'm going to try to sneak that in. I need one more color. Give me that purple. Here it comes. Awesome. Thank you so much. So to graph this then, my parent function is a quadratic. So that would be a parabola like this. Okay? And then the plus b is going to move it to the minus b like that. So we'll move it over here with that belly button point right there. And then this minus Whoops, why is that a y? That should be f of x. How did that get to be a y? I didn't swap the variables, that's what I didn't do. So apologies, but that should be an x. Way back here, that should have been an x, and that should have been the y, and I'm just solving. So I did everything right, but I just didn't swap my variables. I bet you spotted that, and we're probably shouting at the camera. But okay, so that's a minus x, and if I'm changing this sign, that's going to swap it around like that, okay? So that will not change that if I change it this way. And then I'm moving it to the plus b, all right? The squaring gives it the parabola shape, and then this plus a moves it up to here. So this is the shape of the parabola that I've got, okay? But remember my original domain and range, which I wrote down right here, okay? So those are going to swap as well, all right? So my new domain is the old range, but I use an x. So it's going to be x is less than or equal to negative b. That's very important because I've only got half of a parabola here, so I'm not going to sketch a whole parabola here. I've got to know which half it is. So the range then is going to be the swap of the domain, which is that f of x, f to the minus 1 of x, is going to be greater than or equal to a. So which half of the parabola do I get from this? It's the part that's less than negative b. So I take this part away, okay, and this is my inverse right here. And that makes sense because I know it's supposed to be from positive a and above. Then the other thing, do the graph show what you expect? Can I have black? Is there black? I got it in my pocket. Good, I'm good. So the other thing is that do the graphs show what you expect inverses to show? And they're supposed to be reflected about this line right here. So yes, this has been folded over on this wall. This red half of the parabola is up here now where this purple is, okay? So that is the inverse. How are we doing for time?
12 minutes.
12? Okay, that's probably a good place to stop.